operation of your exponential function is, I find it very enjoyable because it is very simple. Since when I differentiate e to the power of x, that is the exponential function, okay, what we get as a result is exactly the same thing. That's why it is simple, right? So e to the power of x, when you differentiate it, you get e to the power of x itself, okay? But then, if I want to differentiate e to the power of, let's say, for example, 4x plus 3, then it may not be that simple because we have to then apply our chain rule. Okay, so what comes out of it is that I will get e to the power of 4x plus 3, just that I must remember to differentiate your 4x plus 3, and that will give us a 4. Okay, so it simplifies to 4e to the power of 4x plus 3. Okay, so that's how we apply our chain rule itself. Alright, so therefore in general, if it's e to the power of fx, we will actually get e to the power of fx itself, followed by the derivative of fx. Okay. So looking at some examples, let's say I want to differentiate x plus 1 times e to the power of x. Okay, so in this case, I'll just let y to be equals to this, so that I can use my notation dy over dx. And what I will get is by doing our product rule, okay, keeping the left side, differentiate the right, because we differentiate e to the power of x, we get e to the power of x itself, followed by adding, keeping the right side, differentiate the left side, we will get 1. Okay, and this can be simplified to this. Okay, but we can also factorize out e to the power of x if I want to simplify it even more by factorizing. That will give us x plus 1 plus 1, and that leaves us with x plus 2 in our brackets. Then when I want to differentiate 2e to the power of x over x, we apply our quotient rule. So another way to present would be like that if I don't want to define y. So apply our quotient rule, we keep the bottom. Differentiating the top is 2e to the power of x. We can just keep the constant as it is. Okay, and differentiate our e to the power of x, which remains the same thing. Okay, then after that we keep the top, differentiate the bottom, we get 1 divided by x squared. Okay. So because whenever we differentiate e to the power of x, it gets us e to the power of x. We usually can simplify by doing our factorization and arrive at this. Okay? Because likely all terms will have e to the power of x itself. We are using fx to define our function e to the power of x minus 1 square, then our presentation will be f prime x. So in this case, we apply our chain rule, okay, because the entire thing is being powered, so-called, okay, we will first have to bring down the power, then power minus 1. Then we apply our chain rule by going inside to differentiate e to the power of x minus 1, and that will give us e to the power of x itself. Okay, minus 1 actually becomes a 0 lah. So I'm just intentionally writing it here so that you are aware what is this supposed to be. simplify it, and we get 2e to the power of x times e to the power of x minus 1. Okay? Any questions so far? I think differentiating exponential is straightforward now, okay? Not as complicated as your sine, cosine, and tangent, right? Let's move on and look at something more complicated. Earlier on, we have our powers all to be in x. Okay. Now our powers are expressions such as 2x plus 1. So if I let y to be equals to this, then my dy over dx would be, as mentioned, we keep the entire thing, then we differentiate the function on top itself, and that will give us 2. Okay. So we will usually write it as 2e to the power of x. 2e to the power of 2x plus 1. Differentiate e to the power of square root x. What do you think the answer will actually be there? Winding can give me an answer. Sorry? E to the power of square root x followed by half then x to the power of negative half. Okay? Alright, so let's do a quick check about this. So, first of all, we keep the function itself, e to the power of square root x, we have kept it here. And then we want to differentiate your square root x. So, this part itself needs to be the differentiation of square root x. So, we recognize that square root x is x to the power of half. So, we bring down the power, half, and then the power minus 1, we get negative half. So therefore, this is the correct derivative of your square root x itself. Okay? And then we try to neaten and tidy things up a little. Okay, so this is half, and then x to the power negative half. So we know that it is the same as writing 1 over 2 square root x. Okay, you can form a single fraction out of it. You can write it as e to the power of square root x over 2 times square root x. Okay? Okay, one final one, we throw in our trigo, okay, into the mix. So in this case, let's say I call this fx, or maybe let's call it gx. Okay, I'm just trying to showcase different presentation now. Maybe up to you how you want to present it. And of course, there are times whereby they already put it that way, so we keep to that. So if I have gx to be equals to e to the power negative x times cosine x, so it's a multiplication over here. Okay, so we apply our product rule. Keeping e to the power negative x, we differentiate our cosine, we will get negative sine x, followed by adding, keeping the right side, and then we differentiate e to the power negative x, that will give us e to the power negative x. But not forgetting that we have to differentiate the negative x, that gives us a negative 1. Okay? So, upon simplification, this would be what we get. But if you like to, we can continue to factorize. can factorize out the negative e to power negative x. That will leave us sine x plus cosine x. Okay. Then if you don't like it to be in negative powers, you can place it as a fraction and put it into the denominator. Okay, multiple ways of presenting your answer. Nothing wrong with leaving your answer like that, but it's not okay if you leave your answer as this, because this negative one you need to simplify it by changing this plus over here. Okay, you could leave your answer this way, or this way. Either one is fine, provided that the question did not ask for certain format. Okay, so you really have to look at the question itself. Sometimes they do require you to leave the answer in a certain format. Then you have to try to achieve that. Okay, questions? Right, so no questions. This is the time for you to practice. Okay, every time we learn something new, go to practice. I want us to do exercise 15.2. Okay, question 1A, C, B, D, 3B, C, 4B, C, 5B, C, and 6B. Okay, I want us to work on these questions now to actually reinforce this idea about differentiating exponential. I'll give you about 20 minutes. How about that? Okay, to work on it in your notebook. Will I run through some of them? Okay, I want to highlight, okay, first thing before I run through any of them, okay, I have a question over here. What is the derivative of e squared? What do you think it is? Is it 2e to the power 1? That means 2e. How many of you think that it will be 2e? Okay, right? This is something that is very important because most people will give me 2e, but that's not correct. Okay, why? Because we're differentiating with what? Differentiating with respect to x. Is there any x over here? There isn't. What exactly is e squared? E squared is just a number. Okay? Then you can press your calculator, it's just a constant value. Just like your numbers 2, 3, 4, half and all that. So actually what should the differentiation be? It should just be 0. Okay? And so please be very clear about it. Because sometimes people get very confused when it is e, they think of algebra, okay, and then after they start to apply the power rule itself. So I want us to be very clear that e to the power 2 upon differentiation, in fact e to the power anything, okay, that is a number itself, you need to recognize that it is a constant number, it is a value, therefore the differentiation will just be 0. Okay, then I think question 1A is straightforward, you just get e to the power of x, okay. For 1C itself, I noticed that for Amelia Cole, okay, what she did was to apply the product rule. Okay, not sure whether the people at the back can see, hopefully you're tall enough. Okay, applying the product rule, that means you keep the left, differentiate the right, keep the right, differentiate the left. Okay, while the application is perfectly done, okay, nothing wrong with it, you do get the answer. My question here is there any other method? Okay, because when it comes to e to the power of 3x over 2, I want us to also be able to see it as differentiating half times e to the power of 3x. Okay? And half is a constant number, just like how we go about differentiating half x cubed. Okay? Differentiating it, I'm not putting equal sign now, will give us half times 3x squared. So logically when it comes to this, because this is a constant, what we can get is that we get half e to the power of 3x. Differentiating 3x, we will get 3 itself. Okay, so that we can directly get our answer 3 over 2 times e to the power of 3x without doing our product. Okay, why is there this risk involved when we do our product rule? Let's wait for the plane to fly. did I want to say? Actually, I forgot. What did I want to say? Oh, okay. I wanted to say using product rule, the risk is that, okay, when you differentiate 2 to the power of negative 1, you must remember that 0. Okay, because if you think there is nothing and then you really leave nothing over there, then you will end up having e to the power of 3x times 1 actually. Okay, because with this 0, it actually multiplies with 0 and it disappears. So we need to be clear that this nothingness concept actually means 0 itself. Okay, while nothing may just mean that it doesn't appear anything, okay, but in this case the number that attached to nothingness is actually 0. Okay, so we must be very careful about that. Alright, then after that, question 2b, Megan decided to do it by product rule, nothing wrong with that as well. Okay, you can also do quotient rule, you will still get the same answer. We get e to the power of x times x minus 2 over x cubed. Okay, the problem would be if you do product rule, you need to do your factorization properly, because in this case you're factorizing x to the power of negative 3 and that is negative powers. So it can be a bit difficult sometimes when you deal with negative powers, okay, or rather negative numbers. Okay, then for you is answer, doing your product rule, she does get an answer, nothing wrong with that as well. Okay, and then after that for Syria and Davian, using your chain rule, the power rule, okay, also perfectly done. Likewise for Ashley and Gladys. Just want to pause over here, any questions regarding this? Okay, these few questions. Right, then after that, for Wayne, okay, as well as Wiley, what was being done is to do by product rule, and because there is trigonometry thrown inside it, so we need to actually be familiar with our trigo differentiation as well. Okay, for Wiley's answer, nothing wrong with it. It is tricky because our power over here is an expression x cubed plus 2x, so we need to actually differentiate it. Okay, because this is supposed to be f prime x. So differentiating x cubed plus 2x will give us 3x squared plus 2, okay, itself. Alright, then after that, we keep the entire function here the same. Okay, so the product rule application is done. Not sure whether the people at the back will find it difficult to see because it's a bit cramped. Maybe I'll just enlarge this. Okay, but this will be the answer that we get. So e to the power of x cubed plus x times 1 plus 3x cubed plus 2x. Okay. Then Joshua's one is probably the most difficult one. Okay, is negative to the 2x. On top. This one. Oh, okay. Thank you for spotting that. Okay, so using our quotient rule, we keep the bottom, differentiate the top. Now the differentiation of the top part is x times cosine x. Then we have to go about doing our product rule. So that is the tricky part. Okay, if you're not familiar with your quotient rule, you will find that this is virtually impossible for you to actually differentiate by product rule, because it is a product of 3 things. Okay, so you have to hold 3 things in your mind when you do your product rule, and that is not going to be easy at all. So if you do your quotient rule, okay, you will know that we're keeping this part here first, then after we differentiate x cosine x, that will give us keeping the x. Okay, wait what do you do over here? Keep left, differentiate right. Okay, let's do a check out. Keep left, differentiate right, we get negative sine x, plus keeping right, differentiate left. Okay, so when you keep left, differentiate right, we get differentiating cosine x, we get negative sine x, and then after that cosine x you keep and differentiate x, you get 1. So what Joshua did was to actually flip them around to express it as cosine x minus x sine x. Nothing wrong with that at all. Okay. Then after that, keeping the top, differentiating the bottom. Okay. Differentiating the bottom, then we have to keep the entire function and differentiate your 1 minus x squared. Differentiating 1 minus x squared gives us negative 2x. Okay. And then we go about doing our simplification. You can factorize out your e to the power 1 minus x squared first. And then we go ahead to actually simplify and arrive at our answer. Okay. Any questions? Definitely this one takes a lot of patience. Okay, but it's really we need more for us to actually train ourselves to be familiar with our differentiation rules. Okay? Okay, with the planes flying by, I don't think I will go into the application part. So at least today, okay, what we have done is to settle, okay, how to learn how to differentiate your exponential functions. Tomorrow we'll go into the application parts. That means going back into our tangent normals, okay, maxima, minima, and then your increasing, decreasing function, those kind of applications. Okay?